Whenever you're ready.
All right. So, welcome everybody to the Mech Workshop number 1. Today we're going to be going over the very high-level design steps, just introduction mostly. I'm going to be introducing CAD and the Homestead Shop.
And if you have any questions about the presentation, just feel free to put them in chat. We'll be looking at that continuously.
So, I don't know if you guys were at the first general meeting, but I'm Nicholas. I'm one of the hardware leads.
And I'm Tommy, and I'm the other hardware lead.
All right. So, well, first to get this out of the way, are we going to be building a robot in the near future? Building, probably not, because we're pretty much closed out of the school, but nothing's stopping us from designing stuff. So that's what we're going to be teaching over the next couple months. Everything from CAD to design. So how does one design a robot? Well, break it up. Designing the robot is pretty hard. So we usually break it down into what you'd call the subsystems. So nobody's really building the entire robot. It's a bunch of people taking on smaller systems, something like an intake or manipulator, or the shooter, or the drive base, things like that, and we bring it together in the end. The stuff we mainly follow here is a pretty simple process. You could call it the engineering process. But they probably went over, they were able to generate, test it, and keep doing that in a pretty short time. But just by following those steps, you can pretty much design anything. That's how we design a robot. That's a pretty simple way to do it. Another question I'd like to get out of the way. Do you need to be good at math to do design? Not really. Basically, you can get by without using a lot of it. It's pretty much CAD. If you're using CAD, it does a lot of the work for you. You're punching in numbers. You don't really need to do too much with even trig or anything. Things up, but knowing geometry could help. So how do we learn design? First off, come in the workshops. We're teaching you pretty much everything you need to know to design things for FRC. Specifically, it's pretty easy formula, and I mean it teaches you how to design things in general, but this would be specifically for FRC. Looking at design, any existing products, looking at robots, cars are another cool thing. If you look at designs, learn what's good about them, know why bad things are bad, you'll be able to learn pretty quickly, and stuff is everywhere. And then get the CAD software and start learning how to use it, and then you can model pretty much anything. Keep practicing that way, and you'll get better. And then the last way, not everybody might have access to this, but 3D printing. Since we don't have access to the shop right now, you could on your own do some 3D printing, and there's a lot of nuances there that you can learn a lot from. All right, so I've been referencing something called CAD. It means computer aided design. It's software, basically. You can see a little screenshot there on the right. Basically, you can draw up 2D sketches, you can make 3D models, and it's really limited by your skill. You can model pretty much anything. That's how pretty much all products in the world are made. They're CAD modeled and then manufactured. So the workflow, I guess, is similar to the engineering process. Come up with a concept, design it, and then we make basically make a drawing from that. And then with that drawing, you can make a physical part. The person who manufactures it will follow that drawing. So after these slides, we'll have the steps to download it. And then I'll show some demos and have you guys follow along. And hopefully you can get the basics down today. And there's just an example right there. Again, another sketch there for a model that we created last year. And we actually made that, manufactured it, and it's in the shop right now. The CAD software we're using is Fusion360. And again, we'll show you how to download it at the end of the presentation.
Okay, so right now we don't have access to our shop, but we're going to show you the basics of what we have. So starting off with the basic machines, we use the drill press and the sander/grinder a lot. So then the drill press would obviously be to put holes in metal and stuff, and then we use the sander to take off small amounts of metal or to smooth the corners so they're not sharp anymore. And then some other tools we use a lot would be the bandsaw, which is a primary tool for cutting metal or wood or really whatever. And then the mill. The mill would be a much more accurate way of doing that, and it can both cut metal and drill holes. As you can see, like this kind of bit would be used to drill holes, or this larger one would be to cut metal, and it's much more accurate. So then we also have some machines we have offsite access to, like CNC routers, as you can see in this video, and then mills.
So these machines here are different from the ones we have in the shop because the ones we have in the shop are all manual machines. So everything you do with it, basically, you're cranking something with your hand or moving something around. These machines, you basically program everything beforehand. So all that movement right there in that video is you just press go and it does its thing for like 10 minutes, 20 minutes, depends.
Yeah, and typically this would be used on like larger, more intricate pieces. So then other tools we have, for example, like this is a caliper. We use this to measure different things. So the way this works would be this number here is the amount of distance between these 2 points of the things. And then you can use that to scratch the metal literally with these points to make accurate measurements on your metal so you know where to cut or where to drill stuff. And then these kinds of tools like the file here and the deburring tool, those would be useful to make sure that things aren't sharp anymore. There's no like residue metal in your holes. And then, yeah. Then center punches, what those are is you use them to basically make a divot in your metal. So that way when you use the drill press, the drill bit actually goes where you want it to go, because otherwise the drill bit can really go wherever, and this helps guide it to be more accurate. And then the squares and scribes. Squares help you make sure that all your cuts are straight. So that way when you measure stuff with calipers and stuff, like you'll be making lines that are also straight along with it, because if it's not, then your line could be crooked, and then therefore when you make your mark, it'll also be crooked. And then, so the basic way we make parts is you start out with a drawing. So like this is an example drawing. So the way you read the drawing is, here's kind of like a main view of what the part would be. And this would be like the different views, like a side view, a top view, a front view. And then it's hard to see, but there's numbers here, and those represent how far away from the edge the middle of this hole would be. Or like these numbers would represent how thick the metal is, which lets you know like what kind of metal you need to get to make this part. So then the basic way to make parts is first you'd find the stock you need, which is, in this case, it'd be 1 inch by 1 inch L stock. And then you'd either mark your piece out of like a cut you need to make, or like center punch where you need a hole. You would cut or drill that piece, and then you just keep repeating that until you've made all your cuts and drilled all your holes. And then you'd file and deburr your piece so it's nice and smooth and won't cut anything. Okay, so.
Sure. So I'll take this. So basically, you guys probably haven't seen, or if you're new, you probably haven't seen many robots, which is probably normal. I don't know why you would have. Maybe if you did for FLL. Anyways, basically, I'll explain kind of what's going on in these robots. First here in the top left, you can see that weirdly placed yellow cube there. Yeah, that was like a 15 by 15 like milk crate basically, and they put like a vinyl covering on it. Anyways, the goal of that year was to take those cubes and move them into basically there was two goals on a field. So there was like a high scale area. So either team had to try to bounce it onto their side, and then there was a low one as well. So those black wheel roller thingies were supposed to, or were designed to suck up the cube into those basically that claw arm thing there. And if you see in the picture on the left, it's stowed inside because it could flip in and out and score on either side of the robot. This gold one in the middle here, it was designed to move that big yellow ball or orange ball you see on the right there, and basically score into three different goals. Some of them were high up, some of them were low. It's an example of one of the that type of mechanism. The one on the far right here, this is one of our robots. This is an example of there's two ways to do one task, or there's more than two, but right here we have a claw versus this roller mechanism. This claw was used to do the same task of moving this orange ball into both a high and low goal. And then in the front there, that's a bit more of a traditional, what you hear called an intake. So that would roll the balls in off the floor. And then in the center there, there's another robot. One of the functions of that was that little yellow wiffle ball there in the center, that like tower thing. That's a shooter. If you might be able to see, there's a little yellow like wheel right there. So that would spin up really fast to like 5,000, 6,000 RPM, and basically you just it would feed the balls through the bottom there, and it would shoot out like 20 or 30 of them in like 5 seconds or something, super fast. But yeah, I just wanted to show some robots off in case, because we probably aren't going to have many opportunities to see them in person, at least in the first semester. So we'll be showing a bunch more over the next couple of weeks because that's how we're going to learn design.
Okay, so Nick, did you want to share your screen for that?
Why don't we just, you can just go through the video, yeah.
Okay.
I mean,
So
just
then
pause in between. All right, so first note here, this doesn't really work on a Chromebook because it works for Windows and Mac. So if you don't have if you have a Chromebook, kind of stuck because normally in the Homestead lab we would have there's laptops there you can use, but here I honestly don't really know what. So yeah. Anyways, you see in the bottom there, you can look up Autodesk Education and then just open the first link.
Yep.
And just follow the instructions here.
There'll be a button that says Get Products. You can click on that. And you're gonna want to click Get Started. So then that'll prompt you to make an account. Make sure you use your school email so that way you can get it for free. So it'll just ask you some basic information like where's your school and all that stuff.
Yeah, to be clear, under no circumstances should you need to pay like at all. This is free software.
Yeah.
So if that happens, something's going wrong. And I mean, you could just let us know. We can figure out. But yeah, you're gonna have to create an account.
Yes,
It
you
doesn't
need
matter
your
which, or you could use your school email or a different account.
yeah, your school email would be easiest though. Just see name, email, password. So after you create your account, you have to go to your email and verify your email before you can progress further. Then after you verify, you have to enter a little bit more information about your school.
All right, why don't we pause here? Just make sure
Yeah.
everybody's staying up.
If you need any help, anything went wrong, you can just send a
Yeah.
message to me and Nick in chat.
All
Or
right, why
just
don't you guys
everyone.
thumbs up once you guys create your account?
Yeah.
Do this thing.
And if you need us to go back a little bit, just again send us a message.
Tommy?
Yeah.
The website. I forget. It was like
Website.
Autodesk
Okay.
something.
Autodesk. Just look up Autodesk.
Hey, education.
Autodesk Education. It'll be the first result.
Inventor's probably fine, but yeah, pretty much it's
Okay.
fine.
So
Yeah.
you verified your email, but that's not a next step.
You should make
Then
the account now since
yeah, you
yeah, we're gonna
can.
be going over some stuff. Like I'm gonna be doing like some demos and just teaching
So
everybody how to use the basics.
to the person who verified the email, but you're not seeing the next step, maybe try just going back to the original Autodesk Education page and be clicking the Get Started button, because now you have an account and you'll be signed in. Yes, this meeting is being recorded and it will be posted. And additionally, we will send out all the slides and links of this presentation.
What the- Yeah, if the other link isn't working, or like just to get to it, you could just try that link. I think that goes directly to the page.
Oh
No, I
yeah,
mean,
that does.
you still gotta get the account and everything. All right, how we doing? We
Everyone
make it like a thumbs up if you're done.
will use the yes and no thing too,
Oh yeah,
because those
making
stay
the
longer.
account. All right, sick, we're almost there.
Okay. We'll just wait a little bit longer, then we'll continue. Okay, anyone else with any more issues, anything? Or can we keep going?
All right.
Okay.
Are we good to move on? Anybody still getting the accounts? Or...
Okay, looks like we're pretty good.
All right.
So I just ask you a few more questions, like
That's...
graduation. I just put in something random because I forgot. Then continue. So then now when you go to CAD, it may ask you to verify verify your school information. It may not. Make sure it's all correct. Then you can continue. And then it'll ask you to upload some documentation. So just like a photo of your student ID will work.
This is basically because you can get this free under an education license. So
Yeah,
I think this is so that they can kind of confirm that.
yeah. We'll pause after this section. So then after that, uh, you will get an email saying that's been confirmed, which will look like this. So I'll pause here for a bit.
But you don't have to wait for the confirmation thing, right?
It's set up to 20 minutes, but in this case
No.
here, it happens immediately, but it has said 20 minutes before. It said 20 minutes in the thing before,
I've
so
seen it. I think you can use it without anyway. It'll consider you
yeah,
under free trial.
yeah.
So it doesn't really matter.
Yeah. Okay, so to confirm your eligibility for access, you need to upload some sort of school document to prove that you are like education stuff. So then I recommend just taking a photo of your student ID and uploading that.
Oh, if it hasn't asked, then just ignore it. Pretty
Yeah.
much.
Uh, if you don't see it, like then you don't have to do that. But if you do, that you'll have to. So,
Yeah.
but
Because I remember. Yeah, I remember it. There's times where it hasn't for me, but I think when I reset my password at some point, it made me. So I don't know. I think it's a little bit random.
yeah. So if you don't see it, you're good to go.
again, like if it doesn't work with this licensing today anyways, it'll register you under the trial for a little bit.
Mhm.
It'll probably work out later though.
Yeah, so then you have like, what, 2 weeks to get it working too. So you'll be good either way.
Can we have show of hands again for who's up to this
Yeah.
point?
Okay, we'll wait a few more moments, then we'll move on.
We'll make that then, yeah. All right.
Yeah.
It's a good.
So then on your email, just click get products and then go back. You want to click, s- sometimes this button won't work. You can click like the sign in or the get started button here, excuse me. And then get product access, and then it'll prompt you to install it. Okay, so I'm gonna go back and try that again. So get products from your email. You want to click this big get started button up here, and then that'll allow you to click get product under Fusion 360. Then I'll install in Chrome or whatever browser, and then how long does it take for the email to come after submitting the photo? Uh, I mean, like, I've had it come instantly, but the website also warns that it could take up to 20 minutes. But if you don't get an email, see if you can download it, and if not, you might have to wait.
Yeah, just try to
Yeah.
download. I think it'll work.
You still get a 2-week free trial, regardless of if you're verified for education or not.
After you press get started. Did you try the link? Try the link in chat.
Oh, try to click the big get started button in blue here.
Yeah, you could try that
I've
too.
had this button not work. So if you click this big get started button, the next page will allow you to click get product. Okay, can we get like some thumbs up if you kind of like following along and like kind of at the step?
Yeah, I guess this is pretty much the last step since
Yeah.
you should be downloading it after this.
Okay, so then I'm just gonna keep on going then. After you download it, you're just gonna have to sign in again. And
Oh, did you use your school email at any point?
yeah, it needs to be get the education access.
Um,
If hmm,
Here, can you share your screen?
uh,
Oh, actually, no, I haven't. No. Is there an option to just get a free trial?
It says I can get a free trial. Yeah.
Okay, because I've seen it where you get it like runs on a free trial for like an hour, and then after that it's good.
Oh.
Yeah, why don't you just run on that right now? And then later we can figure it out if it
yeah.
doesn't fix itself.
Okay.
Okay. So after you sign in, you'll be prompted to create your own team. And then just choose whatever team name you want. Then put it as do not allow discovery, so it'll just be your own thing. That'll finish setting up, and then you should be done by then.
After that, you should pretty much be in. Can't download it. Oh
Yep.
shoot. What do you see right now? Would you have any ad blockers on?
I don't think I do, but I can go get started and then have all the programs pop up. But then when I press the blue get started, nothing happens. No,
Do you see
and
a?
it's not just with the Fusion 360; it's with all of them.
So are you on? Is it? Wait,
Right before that, yeah.
this
When I
page?
press that, nothing happens.
This big blue button too?
Yeah. When I
Okay.
press that, those show up at the bottom, all the different apps, but then I'm just stuck there.
What the heck? Here, did you try the link in the chat? Just like the super long
Yep.
one. Let me- Get Fusion for free. Oh, that links you back to here. Shoot.
Oh
Oh,
gosh, nope.
actually, it links you to Fusion 360.
That just puts Fusion 360 in the search bar.
That still doesn't work.
No.
All right. Why don't here we can figure this out probably after in the Slack channel. Yeah, we should also be doing that. Yeah, I'll just put the link in here for the Slack channel. If you don't know what that is, it's basically like
Discord.
yeah, if you know what Discord is, it's basically like Discord but like professional. So there's
Yeah,
a team one.
I think past this point, if you're having individual problems, either send a message on Slack, email, or find it so we can find another time and help you sort it out.
We'll wait like one more minute, and then basically what I want to get past today is basically just like a quick introduction, since the software when you open it, it's kind of like confusing because there's a lot of stuff that you can do. So I'll just show you the main features that we'll be using. If you don't have it, like it's not working, if you still can't get it to work after like a few minutes, you could just follow along, since it's just the very basics. Like you won't be missing that much if you can't use it. And then maybe Johnny can help you out and try to work it out.
Or since we'll be sending out the slides after this workshop, if you figure it out on your own time, then feel free to try it out as well.
Nick, did you want to share your screen now?
You have to stop sharing.
Okay.
All right. So yeah, if you can't get it to work, like if you're like signing in right now, I guess you can do that. But if it's like a little more complicated than that, then just leave it. It's okay. All right, so I'll show a couple examples and just some of the main features. All right. So can everybody see this? Yeah. Okay. Yeah, it's good. It's good. All right. So basically, when you open up Fusion 360, this is what you're gonna see. It might look a little different since I have features up at the top pinned, and it'll probably have this layout grid. So that's the first thing we should do, is turn that off, because that's something that'll turn on when you go into sketch mode. So it's good to have that so you can differentiate which mode you're in, and also it gets kind of confusing. So to do that, there's just this little icon down here. It says grid and shapes, or snaps. And that, just click on it, and then uncheck that layout grid. And then you should just have a blank white space. All right. And then the second thing I like to change is this thing here. It says set increments. And once that goes, you should have these increments on the right here. It's probably set to adaptive. I change it to fixed. And then linear increments, I change that to 0.0001. And then rotational increments, 0.01. And basically, it's probably going to default to something a lot larger, like 0.1. And it just kind of slows you down, because in sketching and like extrusions in 3D, it'll basically like lock to positions like in a 0.1 increment. And when we're working with like robotic stuff, we're working with a little bit more precision than that. So I find it easier to just have the number smaller. But other than that, you're pretty much all set up right off the bat with software, or with like the setup stuff. So here, I'm going to start off and just show an example of a pretty simple model I made a couple weeks ago. This is the basically the screen door handle in my house. It broke, right? So I thought, okay, I can just 3D print another one. But in order to do that, I have to model it, right? So first off, the bottom here, this is called the timeline. So this is all the features I use to basically model it. So you should see at the bottom, they're in like you should probably have a blank document here. There's this area here. I'll just roll this back really quick. And I'll just explain the process of how I modeled it. And then right after that, we can try it yourself. So I start off with a sketch here, and it looks like an environment kind of like this. For some reason, it goes dark for me whenever I go in it, like half the time. I don't know why. It doesn't matter. So you just go with that. That's just kind of how it is. And basically, you make like, there's all these features up here. There's like a rectangle tool, like that. You create, and you can basically just create all sorts of shapes: circles, rectangles, like hexagons, and whatnot. So here I basically made just a couple rectangles, and then you bring it into 3D by using the extrude function. So it's the second one. So these two up the top here, the extrude and sketch, are basically your building blocks. Extrude basically allows, it's the main feature you're going to use to bring sketches from 2D to 3D. And then after this, I have my main block. And then we're going to add on this pocket feature, okay, since that's the door handle. And then what else do we need? We have these bores out for screws or whatever at the top. And then here I create another sketch for the back portion because there needs to be some clearance. So I use the extrude function again. You can see it in the timeline here, every function I use. And then I put some chamfers on the bottom edge. That's this angle feature here. And then going through it, I put a couple more pockets. I put a little notch cutout there. And then I put some notch cutouts here and some fillets, which is this round thing here. So it allows me to make these sharp corners like that round. And then after that, I'm done. So that was a little bit to go over in a short time, but I'm going to show you how to model this camera thing. So if you've taken Intro to Engineering, you probably know about the cursed camera. It's kind of a camera, not really. It looks kind of like one, but it's pretty simple to model, and I'm going to have you guys follow along with me. All right. So here, I'll have this as final model here. So right now you should be looking at this, right? Why don't you start out and click in the top left here. It says Create Sketch. Just click on that, and you'll probably see these weird 3 things open up. So these are the X, Y, and Z axis, and these are the planes on them. It doesn't really matter which one you click on. So if you see, you can move your mouse over one of the squares and just click on one. And then it should probably move your camera, and you'll see a flat face like this. All right, and now this is, you're in a sketching environment, and you're creating a 2D sketch right now. So now that we're here, the first feature we want is the main body of the camera, right? So you can take the rectangle tool in the top here and just click it. You can also press R and just click once on the screen, and then you just drag it over, and then you can either click again and then press, and you can start dimensioning it. But what you can also do is just click once, drag it over, and you should see that there's two like inputs you can put in here. So I put in 3 inches. Oh, yeah, you might have to zoom out a bit. So 3 inches for the, I guess that's the Y dimension, and then 6 inches for the X dimension. So just like that, you've created a 3x6 rectangle. So wait a second for everybody to get that. All right, so basically now that you have a rectangle, it's probably just floating in space right now, like this, so you can drag it around. So that's what we do not want. Basically, if the lines are blue, they are considered not fully constrained, right? So if that happens, you're probably missing a key dimension. That's one thing. And two, things can move around. So if somebody opens up your sketch and accidentally drags, right, your rectangle can move off. And if they click OK, the rest of your model will update, and then your rectangle might be off and you might have no idea. And also, there might be a key dimension like the height based off the floor or something that you didn't define, and it's just a random number. Sometimes that might be okay, but sometimes that might be a problem. So the goal is to make these sketches basically go black. So since it was floating in space, it can move around and everything, but it comes up to millimeters. Oh, right. So in the top right, you just click, yeah, okay. So it defaults to millimeters. Yeah, we should change to inches since that's what we model in robotics. So in preferences, in the top right, you just click on the little initials, click preferences, and then it usually lags a bit. And there we go. And then you can just click on design on the top left. That's not it.
It's under default units, Nick.
It's default. It's in the bottom. Oh, yeah, unit display. There it is. Default units, design. Here we go. It's in the bottom. Default units, design, and just change this from millimeters to inches. Like that. Apply, okay. And then also another note, whenever you're typing in dimensions, you can just change it for the end. You can make this feet if you want. You can make this millimeters, you can make this inches, you can make it whatever. Anyways, we have a rectangle now, and you don't really have to constrain it in space, but the way I did it was I put a line across the middle, and then I used this midpoint tool. I don't know if it's in the toolbar, but it'll basically take the middle of a selected line, so this center line going across, and then I clicked on the center of the origin, so it locks it to the middle. All right. So right now we've just created a sketch, 2D sketch, and it should be just floating in space right now. So the next thing we want to do is bring this 2D sketch into 3 dimensions. So we're going to do that by using the extrude tool. So it should be in the top left. You could also press E. And then, oh, okay, locked onto the sketch anyway. Or if it doesn't do that, you can just left click inside. And you should pretty much get an arrow here and also an input. So you can drag the arrow out and it'll give you increments, but it's best to just type in. So I'm going to put in 1.5 inches, 1.5, and just press enter or OK on the right side. And boom, you just modeled a rectangular block. All right. So now that we have that, we want to start adding on our other features, right? We have this circular feature in the front. We have this cut. We have this weird flash thing and a button. So quite simply, just make another sketch right here in the top left. And now this time you click on, instead of this origin, you want to click on the face. So right now, this plane that we've chosen that the sketch is going to be on is against the front of the block. And then really easy now, just select the circle and it should lock onto the origin. If it didn't do that though, because it's not centered, you can press P, and that's the project function. Should be in here somewhere. Anyways, I just press P, and you can click on a face, and that brings any geometry, even if it's in like a different, I guess, Z or whatever, different depth, and it'll project it onto a 2D plane, onto a 2D sketch. And what I did there is basically just got these outer edge lines to actually show up so I can lock onto them. And now, if you create a diagonal line, you can find the center of it, and right there, put a circle. So just use the circle tool here, center circle. And then I just put 2.75, press enter, there's a circle, boom, extrude. And then extrude it, 0.75, putting in random numbers. So just like that, we have modeled pretty simple circle and block. Let's keep practicing that one more time. So we can do these top features here. I'll show you another way. Or yeah, I'll show you the top feature and then I'll show you the cut here. And then time's gonna be up. So with that, we should pretty much have covered the basics, but again, simple stuff. We're gonna project the face here. Find the center of it, so it can make a diagonal line. And then this time you can use another rectangle here. If you go to the drop down rectangle, you can click center rectangle here. So center rectangle will, instead of sketching on the corner, making like the edges, it'll center it. It'll start from the center and it'll draw it out kind of like a circle. All right, I'm just gonna put in 0.8, 0.5, some more random numbers. And here's another thing you can do in the sketching environment. What you've been, for the past two features, we made new sketches for each of the features, but you can actually put two features, or as many as you want really, in one sketch. So I'm gonna make a circle here. It's floating in space, so I'm going to create a horizontal line starting from this rectangle here, and it should lock to be horizontal. And you can actually just drag this circle, or you can use this coincide tool here, and these are the constraints, onto that dot there. So now it can't move up and down, but it can move left and right still. So here's another feature, the sketch dimension, or you could press D and just click on that line and drag upwards. Left click again, and now you can put in dimension for that line. So I could put 3. That's a little far. 2.75, still too far. Cool. So now we have a circle and a rectangle on a 2D plane on top of this camera thing. So now we can do extrude again. And since they're going to be at different heights, we can extrude this one 1/2 inch. And this is a default feature where basically sketches will disappear, or they'll hide themselves after you extrude. So on the left here, it probably looks like this right now. This is called the browser. Sometimes you might accidentally drag this out. It's okay, you can just slam it into the side again like that. And you can collapse it sometimes. You should just know that it's possible to happen. So if it disappears, sometimes look for that. Anyways, right now what the sketches you've been making are nested under the folder named sketches, and you've probably made the third one here, and it just hid itself. So this little eyeball here, you can click on it and it'll re-show that sketch, and by doing that you can use that sketch one more time and then extrude this button 0.1 inches, and then you can hide it again. And then for the last thing here today, I'll show you how to do an extrude cut. So I started to sketch on this face once again. Hello. All right. And then I'm going to create a rectangle. Just putting in more arbitrary numbers. And I'm not going to constrain it there. And then, so for extrude, you can not only create 3D models, basically draw them out, but you can cut with them too. So instead of pulling out, you just drag it into the surface and it'll go red there to cut. You could also go from operation here and change it to cut. And okay, and just like that, you make a pocket. But all right, that's pretty much the basics that you need to know. Once it gets a little more fancy, you can start actually plotting out like holes and stuff. But a lot of the stuff we make in robotics is literally just a sketch. You drag into 2D, or you drag into 3D, and then you make some holes. But that's pretty much it for today. Time's up, 5 o'clock. So the only thing I would say is make sure to join Slack, because that's one of the main ways we're going to be doing like short communication, like not like announcing things for meetings, but like reminders and stuff for mechanical teams specifically, and just like information, like resources. So yeah, I think
Additionally, we have a collection of some videos we recommend to help learn CAD. So then that will be in the Slack too.
all right.
If you have any questions.
Yeah, we'll be around here for a little longer. But yeah, you guys should go. And then we have our tech workshop next for programming stuff. That's at 5:15.